If you look at this expression or this problem, there are two schools of thought as to exactly what the right answer should be. And both of them use the order of operations to a certain point. So if you look at the fact that we must take the 1 plus 2 and get 3, then it is according to the rules of operations for both schools. And let's just revisit those order of operations rules. We've got the one that says it's BOTMAS, and the other one says PEMDAS. Now, both of them agree that it should come first, because you've got brackets and parentheses meaning the same thing. BOTMAS says there's a word of, like half of something or a percentage of something, whereas PEMDAS refers to E as exponents that comes first. However, if you look at the D and the M, which stands for division and multiplication, and M and D in PEMDAS, multiplication and division, there's a difference in the order. Both of them have addition and subtraction from the order of operations side, but the multiplication and the division seems to be swapped around in the two abbreviations, whereas both of them refer to the same thing, the order of operations. Technically speaking, exponents are just the same as multiplication. Unless it is inside a set of brackets, then obviously the brackets rule comes in first. The word of is also like a multiplication, because if you have half of 20, we replace the word of with multiplication. So if you have half of 20, we write it as a half times by 20, and then you just take it as normal multiplication of fractions further. So essentially the word of is also multiplication, but it has a preferential place before multiplication in the general sense of the word, so there should have been an O there. Just saying that the word of actually has higher priority than normal multiplication and division. And there's also no problem with that. The whole thing comes in with, what do you do with division and multiplication if you get them in the same number sentence? How do you treat it then? Is it division first or multiplication first? Because according to the order of operations, they have the same order. But what if they come in the same number sentence? And to just address that, the rule of the order of operations says, let's just work from left to right. Let's just get consensus about this. Everybody works with the same guidelines. We work from left to right. And if you do that, it doesn't make the other one wrong and this one right. It's just now suddenly everybody should get the same answer because we are following certain guidelines. There's no universal mathematical law that says it should be like this. It's just convention. All the mathematicians came together, or a lot of mathematicians came together and said to themselves and agreed, let's do it this way. Let's just take it from left to right. Now that being said, if you look at the original question and you divide first, then you'll get 6 divided by 2, and then between the 2 and the bracket there is a multiplication. It's known as the distributive law. So you'll multiply the 2 into the brackets. And the answer of the brackets is 3. 1 plus 2 is equal to 3. So essentially then, the one school of thought will say divide first and then multiply with 3, which will then give us 6 divided by 2 is 3 times by 3 is equal to 9. The other way of looking at this will be to multiply the brackets out first. So that will then give us 6 divided by 2 times by 3. So we have to multiply first. By writing it as a fraction like that, we are forcing the multiplication before the division. So that will then give us 6 divided by 6, and it's equal to 1. So you can already see the problem here. We get two completely different answers from the original question. The original same question gives us two answers. And then if we look at what we have over here, we have a so-called proof over here that wants to prove that this is the correct answer, which means that is the correct way of going about it. But let's analyze this. Essentially, what this proof comes down to is they've said, let's take that 1. We could have taken any of the numbers, but let's take the 1 and make it equal to x. Now, then we will solve an algebraic equation. And if we get that x is equal to 1, then we know that that technique is correct, because obviously we know that we've started with the 1. So that's the only real possible answer that we can get. And then we've got these two proofs. So you'll see there that the x has been, or the 1 has been replaced with an x, and then following normal algebraic rules, we get that x is equal to minus 5 over 3 and x is equal to 1, which seems to indicate that the original technique that we've had over here, where we use the 9, must be wrong, because we don't get x is equal to 1 at the end, whereas we do get it there. So if you use the answer of the original question, that's essentially what was done there. Take the original question, make it equal to 9, which is what this answer should be, and make it equal to 1, which is what that answer should be, and see if you get the same answer for x. And then basically that seems to indicate that that technique obviously is wrong. But if you analyze this very carefully, you'll realize that this technique was used to prove that that answer is correct. But that same technique was used to prove that that answer is incorrect. So you can't use the technique that you've used to prove that your technique is right. You have to subject it to a couple of other parameters as well. And just to prove the point, let's take a look at the two equations that we've got, or the two expressions. We've got 6 divided by 2 times by 2 plus x is equal to 9, and we've got 6 divided by 2 times by 2 plus x is equal to 1. Now we'll take both of those expressions and subject it to both techniques. So both of them will be split into 2. The one will then use the technique of divide first before you multiply by saying 6 divided by 2 multiplied by 2 plus x is equal to 9. And then we'll use the other technique as well, where we'll say the multiply first below the line and then make it equal to 9, and then solve for x in both cases. But we have to do the same for the other technique as well. So we'll say 6 divided by 2 times by 2 plus x is equal to 1, and 6 divided by 2 times by 2 plus, not that technique, not 6 divided by 2, 6 divided by 2 times by 2 plus x, multiply below the line first, equal to 1. So looking at the left-hand side one, we'll get 3 times by 2 plus x is equal to 9. Divide both sides by 3 and we'll get 2 plus x is equal to 3, and therefore x is equal to 1. Normal algebraic equation techniques, nothing strange about that. The one in orange will give us 6 over 4 plus 2x is equal to 9, which if you work it out will come down to this. Exactly the same as that. And then you'll get x is equal to minus 5 over 3, which seems to indicate that this technique is wrong. However, if we use the one on the right hand side, according to the same 2 set of rules, we'll get 3 times by 2 plus x is equal to 1. So then 2 plus x is equal to a third, and x is therefore equal to minus 1 and a third. So suddenly this doesn't make sense anymore, because we've used the 1 and we've used just the other technique, and now suddenly we've proven that that is definitely not right. This is right. So essentially what it comes down to is that you cannot prove that you are right by using your thinking to prove it. You have to subject it to something else. And when we take these two answers and we subject it to the other technique, both of them fall out of the bus. That one falls out and that one falls out. Which brings us back to the original idea of the order of operations. How do we solve this? How do we get around this? And the only way to do this is to say, as far as division and multiplication is concerned, and to the same extent addition and subtraction, in the same number sentence, where no other rules apply, just simply take it from left to right, and that then brings us back to the original 2 answers, and this has to be the correct one, because it divided first before it multiplied.